So, from first law of thermodynamics, dq is equal to du plus pdv. Now, dq by dt at constant volume, that means which is Cv, the amount of heat needed per unit change in temperature at constant volume is called Cv. If we integrate this first law equation, that means dq by dt at constant volume is equal to du by dt at constant volume. This term will vanish because we are doing the experiment at constant volume plus 0. So, and this is also Cv. So, du we can write Cv dt. So, the first law of thermodynamics become dq is equal to Cv dt plus P dv. Again we know Cp minus Cv is equal to R. So, this equation becomes Cp minus R dt plus P dv is equal to Cp dt minus R dt plus P dv. Now, for ideal gas, Pv is equal to RT, that means P dv plus V dp is equal to R dt. That means P dv minus R dt is equal to minus V dp. So, this equation becomes Cp dt minus V dp. That means P dv minus R dt is equal to minus V dp, Cp dt minus V dp. So, it dq dq we can write is equal to Cv dt plus P dv or Cp dt minus V dp. Very important equation. You have to remember both of these terms because both of this equation, because if it is experiment is performed at constant volume, then dq is equal to Cv dt plus V dp. If the experiment is performed at constant pressure, the equation becomes Cp dt minus V dp. So, and this equation is valid for ideal gas. Now, you see, for adiabatic process, dq equal to Cv dt plus P dv, you know, again Cp dt minus V dp. Both of these equations are true for ideal gas, and for adiabatic process dq is equal to 0 because there is no heat exchange between system and surroundings. So, V dp is equal to Cp dt and P dv is equal to minus Cv dt. Just dividing these two equations 1 and 2, we get V by P dp by dv is equal to minus Cp by Cv is equal to minus gamma. You know, gamma is equal to Cp by Cv. So, just doing some mathematics, dp by p is equal to minus gamma dv by p, and if we integrate, what we will get? Ln p is equal to ln v to the power gamma plus ln k minus. So, ln p plus ln v to the power gamma is equal to ln k. Then what we are getting? P v to the power gamma is equal to constant. This is valid equation for adiabatic process. So, question may come, prove that for adiabatic process P v to the power gamma is equal to constant. And in case of latent heat, latent heat, we considered latent heat when there is a change of phase, change of state. In the change of state, we have discussed previously, temperature remains constant and pressure remains constant. During the latent heat change of state, what will happen? The temperature remains constant and pressure remains constant. So, in case of a latent heat, L equal to first law of thermodynamics, UF minus UI plus P Vf minus Vi. In case of during the change of state, dq becomes L, 80 calorie per gram. In case of latent heat, so L equal to UF minus UI plus P Vf minus Vi. This is the change in internal energy. This is the work done part.